Good morning. We are still reading the Mystery of History, but we've taken a break to look at what's going on in the mid-1700s in science, because science in the Age of Reason gives us what's going on in the mid-1700s. So we had been discussing Lavoisier, and he had talked about the conservation of mass, and that is you can't create matter and you can't destroy matter. You can't create if you do some type of experiment and the substance changes form from maybe solid to liquid, or from something and they burn it to ash or something, you will still have the same amount of mass no matter what. So you can't create matter and you can't destroy it. He also looked at combustion, and we found that combustion actually goes on inside of your body system, because that's how your body gets energy from food. So now we're going to look at page 31 and Lavoisier and the elements. Natural philosophers have been using the term element for a long time. In fact, back in the 4th century, which means in the 4th century BC. So what does that mean? Hold on. Does that mean the 300s BC or the 500s BC? Hold on, let's see. 0, 1, 2. I think it's the 300s BC. Those always confuse me. Aristotle suggested that all of the things... Cal, that's a little loud, babe. Aristotle suggested that all of the things we see around us are made up of 5 elements: earth, air, fire, water, and ether. Was that right? No. But I think one of the things is... Okay, Cal, I need you to play with something a little bit quieter, please. Okay. One of the things that is important is they didn't let go of Aristotle's ideas very easily, even when there were a couple other scientists who pretty well showed that he was wrong. They didn't let go of his ideas because he was so well respected, and they just said, well, they were like, well, it's Aristotle. Of course he's right. So anyway, I say that to say it's important that we investigate ideas and thoughts according to God's word. Make sure that it agrees and with the evidence that's there, because the evidence should agree with God's word and with the evidence that you are uncovering. So, by the 1700s, natural philosophers had rejected most of this idea, but they still thought that water was an element, until Cavendish showed otherwise. Lavoisier also did some experiments that showed that water was not an element. Lavoisier realized it was time to completely revamp the idea and understanding of what an element is. He defined an element as something that cannot be broken down into simpler substances. So if the water molecule is what?
Water molecule is it's atoms of water.
H2O. It has how many?
So 1 second. 2 hydrogen and 1 oxygen.
So we can break down the water molecule into 2 hydrogen atoms and 1 oxygen atom. Cruz, that's loud. I need y'all to play with something that's quiet, please.
Okay.
So that's what he means by the elements. Once you get the element of hydrogen, you can't break it down any farther. Now you can dissect. They have these super machines these days where you can break up an atom and you can see what's inside the atom, like you're cracking open an egg. But yeah, that's hard to explain. But they're saying the basic elements that without this huge, that they're basically the basic building blocks for matter. That's a better understanding. Yeah. Okay. So, let's see. Oh, he was taking the idea of a flashlight. He was talking about the parts in a flashlight are simple, but each one of them was simpler than the flashlight. So in the end, we know that a flashlight, he was comparing a flashlight to like a molecule and the things that make up the flashlight to an element, because you can break down, if you break apart a flashlight, you can break it down into its components.
Yeah, flashlights back then?
No, this was not Lavoisier, sorry. The author, Dr. Weil, said you could take a flashlight just to kind of get an idea of how you break down molecules into atoms, and so the atom is the same thing as an element, basically. When it comes to chemicals, the conservation of mass can help us determine whether or not we are decomposing or breaking down a substance into smaller, simpler substances. For example, consider iron pyrite. It's commonly called fool's gold. Here's a picture of iron pyrite. It looks a lot like gold, but it's not. It is useful, but not worth nearly as much as gold. A person might get excited when he finds it, only to be disappointed later when he learns it's not worth much except in very large quantities. If you do the right kinds of chemical reactions, you can convert 100 grams of pyrite into 53 grams of sulfur and 47 grams of iron. This tells you that pyrite is made of two simpler substances.
What's sulfur?
That is just another substance. I don't even know what we use sulfur for, other than, some sulfur smells bad. But notice that the 53 and 47 crews equal what?
53 and 47.
If you add them up, equal
100.
100, and you started with 100 grams of pyrite, so you come out with the same exact amount. Let's see. He says, however, no matter what you do to the sulfur, you cannot split the sulfur into two different substances. I can convert sulfur into other chemicals, but each time the mass is more than the mass of the sulfur. That tells me I'm adding something, not breaking it down. The same is true for iron. No matter what I change it into, the mass is always more than the mass of the iron. So he's saying if he's changing the iron into something else, like iron oxide or iron pyrite, when he weighs it after he's changed it, it weighs more. The mass is more, the weight is more, because he's added something. So that tells him that iron, he's not breaking down the iron, he's adding to it. So that tells him, iron might not be able to be broken down. If I can't break it down, then what is it?
It's a molecule.
It's an element. The molecule,
That's what I meant, sorry.
the molecules are atoms that are stuck together. And atoms are basically elements. So, no matter what I change, okay, we said that. Okay, iron and sulfur are elements because they can't be broken down into simpler substances. Lavoisier named 33 substances that he thought were elements. That sentence tells us what? He named 33 substances that he thought were elements.
He thought.
It means it's likely that some of those that he named were not actually elements. Some of them he got right, like hydrogen and oxygen, but some of them he got terribly wrong. For example, he called light an element, but it isn't. In fact, light has no mass and takes up no space, so it isn't even made of matter. It's pure energy. But that's hard to understand. Like if somebody hasn't told you that, that's hard to kind of discover. He's just trying to think through his mind, trying to understand it with these definitions that he's created. Like he set these definitions. He's like, okay, I can't break it down. All right, no, I can't break down light. Okay, so it must be an element. As a good natural philosopher, he expected that some parts of his list might be wrong. He realized that some of the things he called elements probably could be separated. But natural philosophers at the time didn't know how. He said that as time went on, new chemical techniques might break down things that natural philosophers could not break down during his day. This relates back to the activity with the flashlight. None of the components or elements of the flashlight are actually elements. They can all be broken down into simpler substances. However, you don't have the ability to break them down, like the batteries in a flashlight. You can't break down safely, anyway, a battery in a flashlight. So they're the simplest things you could break down the flashlight into, like the batteries, I don't know what you call that, the bulb, the cover, the reflector in the flashlight. Now, of course, most things that you know about are not elements, like water, table salt, baking soda, sugar. All of these can be broken down into simpler substances. What do we call these kinds of substances? We call them compounds. It's because things have been compounded together to make it. A compound is made of two or more elements. Water is, Caleb, do you remember what water is made up of?
Gas.
No. 2 hydrogens and 1
Oxygen.
Yes, but I could see how you would think that oxygen is a gas, because it is a gas. It a lot of times exists as a gas. Salt is made up of sodium and chlorine. Some compounds are made of more than one element. Like sugar is made of carbon, hydrogen, and oxygen. Okay, Cruz. Caleb, let me ask you this. Caleb, can you break down an element? Yes or no?
No.
No, good. Cruz, what is a compound?
Something that's compounded together.
It's elements that have been compounded together to form something else. Like hydrogen and oxygen, I compound them together to form
So I have water.
water. But can't just have one hydrogen. I need how many hydrogen atoms? 2. Good. Okay, so that's it. Our next thing we'll be looking at is Luigi Galvani. This is all going on mid-1700s. We're just taking a break from our mystery of history, and because we're seeing what else is going on before, because mystery of history skips right from in the 1700s and it goes very quickly through the mid-1700s, and this gives us a lot of what's going on in the mid-1700s in terms of science. There's a lot going on while the colonies are being made, or are being founded, and while the 7 Years' War is going on. There's a lot of stuff.
7 Years War?
Yeah, we haven't even gotten to that. I wanted to pause because we've got all this other stuff. So we're going to read a few more scientists before we go to the Frederick. I think the Frederick II and the 7 Years' War. We'll probably read about 3 more and then go back and read Frederick and the 7 Years' War. All right. Bye for now.